So now let's have a look at part C for question 6. So we have a line with equation y equals 2x plus k, where k is not equal to 1, so it's not line L. But a new line, which is also a tangent to our circle C. So we want to find the value of the constant k. So one way of doing it is, so I've written down the equation of the tangent y equals 2k plus 1, where k is not equal to 1, and the equation of our circle, okay, which we found in part B. What we could try to do is to substitute in equation 1 into equation 2 and maybe solve them simultaneously. So let's try that first and see where we end up. So y equals 2x plus k, substitute that into equation C. So let's have a go. So we get x minus 7 all squared. That remains the same. Plus y minus 5. But of course, y is our 2x plus k line. 2x plus k minus 5 all squared equals 20. So now what we want to do is multiply out the left-hand side. And I'm just going to write these double brackets out. That way it might be easier to multiply out all the terms using the FOIL method, but we won't spend too long doing that. So 2x plus k minus 5. And something that might help you multiply out the terms is if you consider k minus 5 as one whole term. Okay, so that's your whole constant term, and you're using that to multiply through the rest of the terms in the second bracket. So here, just for this set of brackets, you'll be doing 2x, take the 2x, multiply it by 2x there, and then take 2x again and multiply it by k minus 5. And then you're looking at the whole term of k minus 5, multiply it by 2x, and then multiply k minus 5 by k minus 5. So let's try that. Okay, so this becomes x squared minus 14x plus 49. So you can have a go at that yourself. And then what do we have here? We have plus, just got to be a bit careful, plus 2x times 2x, that's 4x squared. And then we have, what do we have here? 2x times k minus 5. So plus 2x times k minus 5. And then let's move on to the second term of our first bracket, k minus 5, multiplied by 2x again. So that's just plus 2x, k minus 5 again. And then we have our final term, which is k minus 5 times k minus 5. So that's plus k minus 5. It's k minus 5, and that's equal to 20. Okay, let's try cleaning this up a little bit, and we do still have to multiply out these brackets and these ones here. So we're getting x squared minus 14x plus 49 plus 4x squared. Well, we can kind of immediately combine x squared with 4x squared here. So this is going to be 5x squared. And then we have plus 2x times k minus 5. So we have 2xk minus 10x plus 2xk. So now we're doing this when we're playing this up. 2xk minus 10x. And then plus, we have k squared minus 10k plus 25 equals 20. There. Okay, so now let's try cleaning this up a little bit further, and then we can have a think about what our next step is. So 5x squared, that just remains how it is. We do have 40 minus 14x here, minus 10x, minus 10x. So if we add those up, that's minus 20x minus 14x. That's minus 34x. You can sort of like cross out each term once you're done with it if it's easier to keep track of them this way. Again, collecting like terms, so we have 2xk here, 2xk here. Those are the only terms with xk, and more importantly, the only terms with x remaining. So let's just write that as plus 4kx or 4xk. Let's cross those out then. And then what do we have left? We just have constant terms now because k is a constant. So k squared is a constant. So minus 10k, that's a constant. 25 is a constant. 49 is a constant. And then obviously 20 is also a constant. So here, let's just write plus k squared minus 10k plus 25 plus 49. So that's 74 plus 74 equals 20. And here we have to take away 20. So take away 20, take away 20. So we have 5x squared minus 34x plus 4kx plus k squared minus 10k plus 54 equals 0. Okay, so it may not be obvious what to do from here, but if we think about what we actually did here is we substituted the equation of this straight line. We substituted the equation of this straight line, which is a tangent to the circle C. So we substituted the tangent to C into the equation for C. And out of it, we actually get an expression which happens to be a quadratic, right? Because we have our x squared term, we have our x terms. Obviously, we don't know what k is, but once we do, we can very clearly see that these two terms will very easily combine. And so we just get a coefficient with x. And here we also have a constant. So in fact, this equation is in the form ax squared plus bx plus c equals 0. And because this quadratic came from substituting the equation of a straight line which lies at a tangent to our circle to get our quadratic that we have here, then if you remember when we were learning about quadratic graphs and parabolas, we like to look at the discriminant of the graph, or the discriminant of the quadratic, which is b squared minus 4ac. And when that is equal to 0, we only get one value. So we should only get one value for k, which is a tangent, as a tangent to the quadratic. So if we have a quadratic which looks like this, that's the simplest kind, y equals x squared. This is a tangent to the line x equals, y equals 0. So this lies as a tangent to the y equals 0 line. So when we actually look at the discriminant of this is the most basic parabola we could use. B squared minus 4ac should be equal to 0. Obviously, b is actually 0 in this case, and so is c, so it's 0 minus 0 equals 0. So then we can use this expression for the discriminant on our quadratic equation here with an unknown k to potentially find k. So this is one way of doing it. So let's try and see if we get it. So what we now just need to be really careful, like what is A, what is B, and what is C? Because it doesn't look very clean here, and it may not be super clear to you. A is fine because we can see A is just 5, right? So this is A. Okay, so what's B? Well, we have two x terms, so we're going to have to combine the coefficients because we don't know k yet. So our B term is 4k minus 34, right? That's the combination of the two x coefficients. And so that's our B. And then C is our constant value. But these are all constant. So when we add them all together, it will give us our constant value C. But unfortunately, we're going to have to use this expression for K as our C. So let's substitute those all into our discriminant. I'll just label that this is the discriminant. One. So discriminant for one solution to quadratic. And if you're not sure about that, just try and have a look at one of the videos that I've made on looking at the discriminant of parabolas or quadratic expressions. So then let's just substitute in A, B, and C now and see what we get. So for B, we have 4k minus 34 all squared minus 4 times 5 times k squared minus 10k plus 54. And that equals 0. Okay, so let's multiply out these individual terms now. So for 4k, I might just write out the brackets here. 4k minus 34. It's 4k minus 34. Again, this will just make it easier for you to multiply out the terms. We're just using our FOIL method. And then we have minus 4 times 5, that's 20, times k squared minus 10k plus 54 equals 0. So here, let's go through it. 4k times 4k, that's 16k squared. 4k times minus 34. So 4 times 34. So 136. So we're doing minus 136k. And then we have the same thing again, minus 136k. And then we're doing 34 times 34. That's plus 1,156. So we're looking at big numbers now. Minus 20k squared plus 200k. And then we're doing minus 20 times 54. So minus 1,080 equals 0. So now we have everything in terms of k, and it looks like we're going to get a quadratic from this, which is good because technically we have two values of k for which we get a tangent line. But the one we're looking for is the one that is not equal to 1, because the one where k is equal to 1 is just our original L line, right? Which is the one that we don't want. We want our new value for k. Right, so let's simplify first, and hopefully we can get there. So the first thing you'll notice here, just do these two terms here. These two terms are going to combine. Okay, so let's just do 16. What should we do first? Yeah, let's do this first, but of course we could have chosen to look at the k squared terms first. So here we have minus 272k. Just cross those out when you're done with it. But then you have plus 200k. So in fact, this becomes what? Minus 72k. So minus 72k. And then here with our k squared term, we have 16k squared minus 20k squared. So then that becomes minus 4k squared. Minus 4k squared minus 72k. So we're just simplifying, we're collecting like terms and simplifying everything. And the remaining thing to do is our constant term. So we're just doing 1,156 minus 1,080. And so that should just give us plus 76 equals 0. So now multiply through by minus 1, because typically you want your squared variable to have a positive coefficient. It's just easier to solve that way. So then we have 4k squared plus 72k minus 76 equals 0. Okay, so now we want to figure out how we can solve this quadratic. You should be able to notice that we can divide through by 4. So if we divide through by 4, we get k squared here. We get minus 19 here. And then what's 72 divided by 4? So just 18. So we get plus 18k, like that. All right, so now this looks like a much easier quadratic to factorize. So let's do that. Let's factorize this. So we have our two brackets. We have k there equals 0. Now we need two numbers that multiply to give minus 19, but add up to give plus 18. And that's quite easy. It's just going to be 19. We know it's 19 and 1. And then because it's positive 18, it's positive 19 and negative 1. And so k can take on two values, which is k equals 1 and k equals minus 19. And this is exactly what we expect, because our k equals 1 value gives us the original tangent, which is very good. And so it means our second value for k for our second tangent to the circle C happens when k equals minus 19. So then the final answer to part C, if we scroll up to what it actually wants, it's just finding the value of the constant C, of the constant k, sorry. So k equals minus 19, and so the other tangent will have equation y equals 2x minus 19. Okay, and so that's question 6 of the paper done.